Hello guys, welcome to Learning with new video. In this video, we will learn about IPsec tunnel VPN, how to create IPsec tunnel, and what are the function of IPsec tunnel VPN. So IPsec tunnel is a VPN, end-to-end VPN. Suppose if we are in branch 1, so we want to send the data over the internet to our another branch. So in our previous video, we learned about GRE tunnel. The GRE tunnel create over the internet where the data transfer between GRE tunnel is in a non-encrypted form. So in IPsec tunnel, the IPsec tunnel is also created over the internet, and our data transfer through IPsec tunnel is in encrypted form. So it is a layer 3 VPN which create over internet, and when we search or transfer our data from one destination to another destination, the data transfer over the internet uh, uh, in encrypted form. So there is no hacking, or you cannot see the data of any other, because the data in IPsec tunnel transfer in encrypted form. So in this video we will learn about how to create IPsec tunnel, and what are the function of IPsec tunnel. So here I just write some steps of IPsec tunnel VPN, how to create IPsec tunnel VPN. If we want to create IPsec tunnel from this uh, router to this router, so IPsec tunnel is created end to end. Suppose if we want to create IPsec tunnel from this to this, we create IPsec tunnel between layer 3 routers. So this gateway router, from this gateway router to this gateway router, so one of this interface. So if we want to create tunnel from here to here on the here, we use this interface. If we want to create a tunnel from here to here, so we create this interface. So IPsec tunnel is will be created. So let's first of all I will tell you the steps to create the IPsec tunnel. So the IPsec tunnel, first of all, after completing layer 3, first of all we assign IP addresses to all the interfaces. Then we run a routing protocol which is mandatory. First of we have to complete the layer 3 and check the connectivity from here to here. All the connectivity should be set. So now after that we create the IPsec tunnel. So steps of IPsec tunnel is, first of all we have to create the ACL, one of the access control list, either basic or advanced, which allow our this source and this destination from one another. And second step is we create IPsec proposal. In IPsec proposal we define the encryption algorithm and authentication algorithm, and then we create IPsec policy. In IPsec policy uh, we define this ACL and this IPsec proposal which we define, and also uh, define the remote this local address of this interface, and also this local one. This is the remote one. If we see from here, so from here this is the local, and this is the remote. So we also define the local from here, either we are using this one or this one, we define that. And also define the remote, either we are using this one or this one from here. So we define in IPsec policy, and we also define the string keys and SPIs in this. So there are two type of IPsec tunnel VPN. So there are two ways by using we can create the IPsec tunnel, either in manual mode or in IKE mode, where it automatically define the IPsec keys and IPsec string keys and SPIs. In manual mode we manually give the string keys, outbound and inbound keys that we define in it. And the last step is this assign this policy. When we define this policy and we define in this policy the IPsec proposal and IPsec security, and then this policy we have to assign the particular interface. Like if we are making the IPsec tunnel from this interface to this interface. So we define the IPsec uh, policy on that particular interface. So first of all we create a first of all we I will assign the IP address to all the interface and complete the layer 3, and we will check the connectivity from here to here. So I will do it quickly. So first of all you go here in this interface, and in system view interface gigabit ethernet 0/0/0, this interface IP address is 192.168.10.1 and 24, and quit from this interface 1. This 001 is 192.168.20.1 and 24 IP address, sorry, IP address. And the third one is 2. So I have just given the IP addresses to all the interfaces. Now just we give the routing protocol. You can see here I have just given the IP address to all the interfaces. So now we give the routing protocols. So OSPF, we use OSPF 1 area 0, and the network on this router are 10.0, 30.0 and 20.0. So 192.168.10.0, 0.0.0.255. so just given the network. So here I have also given 20 and 30. So we define the network in OSPF. Now we go on router 3. Or router 3 is this one above one. So also define the OSPF area 0, and the network are two network running on this interface was 20.0, 0.0.0.255 and also 40.0, 40.0. okay, 40.0 is running. This one and this one on router 2. So two network are running 30.0 and 50.0. so we will go in system view interface, OSPF 1 area 0, and the network are 192.168.30.0, 0.0.0.255 and also 50.0. So you can see here the in OSPF it creates first of all the neighbor relationship, neighbor urgency. So they exchange their state, init state, two-way state, xstart. If you don't know about this, so watch my video on OSPF multi-area and OSPF v3. So you will see these states. I have given the explanation in that videos. So we on router 2 we also define the network. Now on router 4 we define the network. System view OSPF 1 area 0, and the network are 192.168.40.0, 0.0.0.255 and also 50.0. okay, 50.0. also create a neighbor relationship with this one, because in both side we define the OSPF, and 50.0 and also here is a 60.0. 60.0. Now we go in router 5 and also create system view interface gigabit ethernet 0/0/0. Sorry, we have to define OSPF 1 area 0, and the network are 192.168.60.0, 0.0.0.255, sorry, 255 and also 70.0. Now the neighbor relationship with 60.0 has been created. So now we given the IP addresses and we define the routing protocol. Now we check the connectivity from here to here, either it is reachable or not. so I have given IP address to these PCs as well. So ping 192.168.70.1, which is this interface 70.1. so let's see it's reachable or not. So it will be reachable. First it will the OSPF state will be completed, so it's reachable, you can see here. So now we ping one of this PC to test the connectivity. After that we so PC2 is reachable, you can see here. PC3 also be reachable. Now we uh, create IPsec tunnel from this router to this router. So we use this interface, so this link from here to here to here to create the IPsec tunnel. So from this router and this router, in both router we do the configuration of IPsec tunnel. Both configuration and both interfaces we do the same configuration from here to here. So let's start the configuration of IPsec tunnel VPN. So let's go in this router. First of all we have to create ACL 3001 and rule 5 permit source, permit IP source. What would be the IP source? We have to permit this IP source. And what is the destination? Destination is this one. We have to permit these PCs and go through IPsec tunnel VPN and reach to this destination. We have to define the destination as here as well. So 192.168.10.00.0.0.255 is our source, and what is our destination? 192.168.70.0.0.0.255 whole network. So we create the IPsec ACL. So here also we create the ACL on this router 5, on this interface, or on this router to this route. These are end-to-end router from these users source to destination. So we create IPsec tunnel from here to here. So we do the parallel configuration. We create the ACL here. Now we create on ACL on router 5, which is this one. So we also create ACL 3001 and rule 5 permit IP source 192. From here the source is 70.0's network and destination is 10.0 network. So we define that 70.0.0.0.255 and the destination is 192.168.10.0.0.0.255. so we create the ACL on both the router. Now we have to create the second step is, first step is ACL security. We create the ACL. Second step is we have to create the IPsec proposal. So let's create the IPsec proposal. So how to create? Just write IPsec proposal and we have to give the name of proposal. So just give the name of proposal that h1 is the proposal name. So in proposal we have to define the encryption type and authentication type. So ESP authentication would be SHA-1. If you question mark, so there are different authentication algorithm, so you can use one of them. So if you are using SHA-1 from this side, you have to use the SHA-1 on the other side of interface, because you are creating a tunnel. So both side of tunnel the parameter should be matched. So we use SHA-1 from here, this side, SHA-1 from this side. We also use the SHA-1 from the other side. So just use the similar parameter on both sides, so your IPsec tunnel have to work and transmit the data. So we define the authentication. Now we have to define the encryption algorithm. What encryption algorithm we want to use? Encryption we use, if you question mark, so there are different algorithms, but we use the 3-dash algorithm. You can use any of them. 3 days. Now our IPsec proposal has been created. Let's go in router 5. We also do the same step on router 5. So IPsec proposal, proposal H1. The name of IPsec proposal can be different, but the parameter should be same. So we are using the same names. It doesn't matter. Encryption authentication algorithm is we are using is SHA-1, and the ESP encryption algorithm we are using 3 dash. So our IPsec tunnel proposal has been created. The third step is we have to create the IPsec policy. In IPsec policy, we have to define the ACL security, IPsec proposal, and some other parameters. Let's go in IPsec policy. The name of policy, you have to give the name of, I have given the name of policy as P1. And if you are using you have to use the shared policy or the sequence number. So in this video we use the sequence number. In next video we also do with the shared policy. So just pick any number 10. And so there are two types, as I have given previously, that there are two type of creating IPsec tunnel, either in manual mode or in IKA mode. In manual mode we define the IPsec outbound key and inbound keys in manual mode. If we use this manual mode, we define manually the keys, that 1 2 3 IPsec number, IPsec string keys. And but if we are using the second method, IKE mode use the automatically pick the keys, and it use the different algorithm to pick the keys. So we in this video we use go with the manual mode, and we manually define the IPsec keys, manual mode. And if now you are in IPsec policy in manual mode, so first of all you have to define the security. What security you are using? We are using ICL, which we create previously. This SCL 3001 we created. Okay, now what proposal you are using? Yes, we are using proposal. The name of proposal was H1. In proposal we define our encryption and authentication, so we are calling that proposal in this policy. And now we have to define the tunnel interfaces, the IP address of the tunnel from where we are creating the IPsec tunnel. So we are using this interface, and because we are creating tunnel from here to here, so we are using this interface. So we define the IP address of this local interface. So the tunnel local is 192.168 is 20.1. the interface physical interface 20.1. so we have to define the 68.20.1. and now we have to define the remote interface. What remote? We are using 192.168. This one is the remote one. So 60.1 is the remote, 60.1. so now we are using the manual mode. We have to define the SPI interface, security association. So we have to we have a command SPI security association, SPI security prefix index. Now if you question mark, so we have to define the inbound and outbound security association in IPsec tunnel. So if you learn the theory, so you must have learned about SA security association and SPI security prefix index. So we define this manually. So if we are using inbound, so if you question mark, so ESP, so you have to define here the key. So just remember that if you are defining the SASPI inbound key, so inbound key from here, this interface should be same the outbound of this interface, and the outbound from this interface, outbound key of this interface should be same as the inbound key of this interface. So remember that thing, that the outbound key of this interface should be same as the inbound key of the remote interface of IPsec tunnel, and the outbound of remote interface should be same as the inbound of this interface. So remember this tricky things, so it will be easy to create the IPsec tunnel. So we are defining that 1 2 3 4 5. So this is the our inbound key, and what will be our outbound? SASPI outbound ESP is the what would be our outbound? So just reverse it. We are using reverse the outbound, or either we can use this 5 6 7 8 9. So this is our outbound. So we create the string keys. So also we have to create the security association string keys. So string key inbound. You just use the inbound key and outbound key. So remember that as a string inbound key should be same as the string outbound key of this interface, and string outbound key should be same as the string inbound key of that its remote interface. So remember these things. So inbound key is ESP. It's the question mark. So simple or cipher, you can use simple or cipher, either whatever you use. So I am giving the uh, Huawei. So this is our inbound key, and SPI, sorry, SPI not SPI, string key ESP outbound ESP and simple. So I use Huawei. So for outbound I am using Huawei 123. So here in inbound I will use Huawei 123. For here in string outbound I will use Huawei. So from here SASPI our inbound I will use this one, and for outbound I will use this one, because the outbound is the inbound of this interface. So for this interface inbound is the outbound of this interface, so I will use this key on outbound. So let's go. So we just complete our policy. These are the four things we use in create policy. We have to give the ACL, and then we have to define the proposal that we created, and we have to create the SPI key, and then we have to use the SA string key. So these four things, and also we have to define the tunnel IP address of tunnel, this remote and the local. So the IPsec tunnel has been created, the configuration on this side. So let's create IPsec policy system view, uh, IPsec policy uh, H1 or P1 is a policy name. Whatever policy name you can use from both different both interface, there can be different policy names. So P1 and 10 manual. So in this we have to define the ACL. Sorry, security is our ACL 3001 we define, and the proposal is H1, and the tunnel local is 192.168. Local is 60.1. This is the local. So 60.1 is the local, and sorry, tunnel remote is 10.1. Oh, sorry, 20.1. This is the 20.1 interface. So 192.168.20.1 interface. So this is our local. We have to define the SPI inbound. So outbound of this interface should be inbound of this interface. So inbound is the SASPI. So you can see here SASPI outbound is the inbound of this interface. So just copy 5 6 7 8 and write here inbound 5 6 7 8 9. 5 6 7 8 9 is inbound. Sorry, ESP, and SASPI SPI outbound, and the outbound from here is the inbound is here. What we use here in inbound 1 2 3 4 5. So 1 2 3 4 5 we use, sorry, ESP, I forgot ESP. ESP is encryption algorithm, ESP. So SA string key inbound, for inbound is the outbound of that one. So ESP simple what we use here in outbound. For outbound I have used the Huawei 123. So Huawei 123 is outbound. Huawei 123 is the outbound from here, and inbound for this one, and for here inbound is Huawei. So SA SPI inbound, sorry, string key inbound outbound ESP simple. Outbound from here is inbound of this side. So inbound is Huawei. So remember these little parameter. If these little parameter are differ from both sides, so your IPsec tunnel will not be up and it will not be work. So we just created the IPsec tunnel. Now we have to go in interface, it gigabit 0/0/1, and here we have to assign the IPsec tunnel. So what is the command? IPsec policy P1. We just given the IPsec policy P1. From here we go in this above interface G001 interface gigabit 0/0/1 IPsec policy P1. So we have given the IPsec policy on both sides, so it should work and it should be up. So let's ping, either it's working or not. So our host is not reachable. Let's check what is the problem. Either we do the all the parameter in sequence, or we just make a mistake from both sides. Let's check one. We define the asset security simple Huawei outbound, and inbound is Huawei ESP tunnel proposal H1, and we do the configuration, and we have the command to check the IPsec policy display IPsec policy. So just customer, so you can see here we create the IPsec policy. So IPsec policy name is P1 and the sequence number is 10, which we create sequence number 10 manual, and our local is 20.1 and remote is 60.1 as is right. And we also define the SPI string keys here. So you can see here the string key we use for encryption. Here is the key. So Huawei 123 is a key, and also we use the key, this one, outbound key. For outbound, for inbound we use Huawei and 123. So you can see here, so all the information is put it here, so you can also verify from this side. So display IPsec policy, so you can see here. So the local is this one, remote is this one, and 10 policy name is P1, and ACL 3001 we use. From here 3001 also we use 3001, and string key is this one here, or here to here. So all the keys are fine. So we just check the ping timeout, it will work. So our ping is reachable. So let's see either it's working or not. So we use the trace route, trace RT 192.168.70.2. so you can see here IPsec is working 192.160.1. So what is 60.1? 60.1 is this interface, and then we have 70.2. So you can see here in a normal ping, if we ping, so all the hops, trace route give the all the hops, so from where it pass, but in IPsec tunnel it skip and bypass all the hops and just giving the end of IPsec tunnel, which is this one, end of IPsec tunnel 60.1, and then the destinations. So it means that our IPsec is complete and our IPsec VPN is working. So it bypass all the network on internet and just reach the end of the tunnel. So that's why we use VPN, that we can hide our source and the our network from where we are passing and just reach the end of the tunnel. So this is the working of our IPsec. No, not this, but we also use the Hcia to ensure that either VPN is working or not. So just we ping 192.168.70.2 and -3 is the continue ping. So we are using continue ping, so our data is passing through this interface. Just let's capture this interface of provide shark. So capture G1. So let's see data is passing through this interface or not, or either is encrypted form or simple form. So you can see here our data is passing from white shark, and you can see here the 192.20.1 is our source, which is this one, 20.1, and the destination is 60.1. So 60.1 is our destination, 20.1 is source, and 60.1 is, and this is the reply packet. 20.1 is the destination, and the 60.1 is the source side. And this you can see here the protocol we are using ESP protocol is a encryption protocol. So our packets are passing through this interface in encrypted form. So these are the hello packets which used by OSPF broadcast. So you can say 224.0.0. is a OSPF multicast protocol to send their hello packets to their neighbor, but our data is passing through this interface in encrypted form. So you can see here our data is passing, continuously passing, and our data is in ESP protocol we are using, which is the encrypted protocol. So you can see here data is encrypted form. So that's how we use IPsec tunnel, and that's how we use our VPN to secure our data, so our data is not be stolen or checked by the middleman. So this is all the purpose of IPsec tunnel VPN. So that's all for today's video. If you have any questions, so you can ask in comments. So let's see one more thing. IPsec, sorry, display IPsec statistics ESP by using ESP protocol. So you can see here till now we have output packet gone, the ping packet gone is 140, and the reply of 133 packet has been come. So some packet gets dropped in middle using, so you can see that this packet has been dropped, so there is no reply of this packet. This packet has been dropped, so some packets get dropped in the middle, and so you can see here is the encrypted packet, and the most of the packets we get the reply of. So you, if you refresh again, so you can see here now we have 171 packet has been ping packet has been gone, and 165 reply has been come. So that's all the purpose of IPsec VPN. Hope you like the video and concept. The video is little bit longer, but I hope you enjoy the video. So thank you very much.